Agentic AI is here. These aren't just chatbots, they're autonomous agents that can schedule meetings, trade stocks, even make purchases without waiting for a human click.
Gartner actually predicts that 1/3 of enterprise apps will include agentic AI by 2028, which is actually pretty soon if you think about it. So there's obviously huge potential there, but this level of autonomy brings with it all kinds of governance and security challenges, which Jeff knows all about.
For sure. Unlike rules-based software, these agents learn and adapt in real time. They decide on actions after interpreting data, not just following scripts. That flexibility is great, but it also opens up new attack surfaces. If attackers manipulate the sensing, thinking, or acting functions, they can hijack the whole process.
And in addition to the important role that security plays in agentic AI, there's a good need for governance as well. So in this video, we're going to discuss some of the security threats, governance challenges, and then the recommended safeguards for how those two can come together and make trustworthy AI. So Jeff, I know that you're working with cybersecurity people every single day and you're talking to them about agentic AI. So what are those agentic AI security threats that just keep popping up? And while you talk, I'm going to take some notes for you.
Please do that. Yeah, there's a lot of them to consider, actually. Many of these are threats that we see for AI just in general, but an agent can be a compounding factor. It can basically be a risk amplifier if you're not careful. And the first I'll mention to you is hijacking. You're running an agent. What if I send commands into your agent and I take control of it and now it starts operating on my behalf rather than yours? So I need to put in safeguards that make sure it still stays and it's following my instructions. One of the ways they do that is through a thing called prompt injection. That's the number one attack type according to the Open Worldwide Application Security Project. They say these prompt injections where you insert commands that the organization didn't intend to have happen, and it allows me to get your AI to do things that it wasn't supposed to do. Really hard problem to solve, and an agent can amplify that. An infection is another issue. These models can be infected. A lot of people don't realize that models can be infected just like software can be infected. You can have malware or viruses in software. You can also have similar types of things in a model. And since most people are not creating their own models, they're having to trust, and you need to verify as well. Poisoning of the data. The models are created from data. We use that to train and tune the models. If someone gets in and modifies that information in just subtle ways, it can be devastating later. It's like a little bit of toxin in the drinking water makes all of us sick. So you've got to make sure your data sources are pure. Evasion attacks are cases where I'm able to manipulate the inputs that go into the system, not the model itself, but into the system itself, where it's doing that sensing. And in that case, it may confuse things. If I put something in a little bit different order or obscure it in some way, maybe you and I filter that out and we're used to kind of filling in the blanks and seeing that. But the AI doesn't always think exactly like we do. And it could be confused and give very different results as a result of that. Extraction. So it's not only about stuff going into the AI, it's about what's coming out. Someone might be able to harvest basically our model and do model theft by getting out a piece at a time, seeing how the model operates and recording all of those things and then recreating that. Or using a prompt injection against a hijacked AI agent that then extracts sensitive information from your organization. We've already seen an example of that, a zero-click attack where the user does absolutely nothing and someone sends in an email that then causes data to be exfiltrated. And then the classic denial of service. In denial of service, you've seen this. If you've ever been on the highway at 5 p.m., then there is not enough asphalt for all the cars. You just can't meet the demand. And if someone sends in a request to your agent or sends enough of these kinds of requests, it could be so busy that it cannot keep up with the demand. So therefore, the system is essentially not available to anybody. So that's just an example of some of the attacks that could affect an AI agent. But Josh, how about on the governance side? What kind of threats and issues do you see there?
Well, you know me, Jeff, I like to tell stories. So if it's okay with you, let's kind of frame this up in the form of a story, all right?
Tell me a story, Grant.
Yeah, let's go for it. So we're going to pretend that we have a fictitious recruiting firm and they're using AI agents to handle their job applications. This AI is given the full autonomy to do things like read resumes, schedule interviews, and send out offers. But at some point in the process, it actually sent out an offer without any human approval. So we have to think, how alone should this agent be acting? And when should humans like you and I step in?
Yeah, so you're talking about autonomy versus oversight, and maybe in some of the cases, oversight. What we need is this notion of human in the loop.
Absolutely. So the HR department might ask, why did this happen? But no one can give an exact answer because that reasoning is hidden deep inside this extremely complex model. The humans just, they can't really explain it in plain English.
Yeah, this is an issue about transparency and the model and is explainable. Does it give you results that make sense? Or does it just all of a sudden say 1 + 1 = 73?
Which is correct. I mean, it's not.
Yeah, it might be.
There were also some candidates who weren't hired because the AI actually favored applicants from certain schools or backgrounds because they had biased training data.
Yeah, if you've got biased data, you might miss a really good candidate and you might end up hiring a really bad one. So you want to make sure your data is trained on the full spectrum of that and that it doesn't drift over time. So it might start well,
Right.
but then it starts going down.
Absolutely. And here's the sad news. Here's the kind of the ending to the story. They've actually now been sued for discrimination. So who's responsible? The AI agent? That HR team who's been using it? The vendor they bought it from? Me and Jeff? I don't know.
Accountability, I blame you.
That's fair. Well, I'm the one making up the story. And it sounds like a pretty crazy story, but it's actually pretty realistic of what things could look like if you have ungoverned agents just running wild out there. Now that we've established the scary side, what are your thoughts on recommended safeguards for how you can bring AI and security together?
Well, there's a number of things that you can do in this case. The first point I'll make is you can't secure what you can't see. If you don't know it's there, then you're not going to be aware of it. So you've got to discover all of the AI instances that are in your environment. And in fact, this is something, yeah, you write it in the middle because it affects both governance and security. You can't govern an AI if you're not aware of it, and you can't secure it if you're not aware of it. So for instance, you need tools that will go out and automatically discover the AIs, especially the ones you don't know about. We call those shadow AI, where someone just does an unauthorized recreation of an AI. They can download a model, they can download a platform, put it in a cloud instance, and they're off to the races. So I need to discover all of those. Then I take all the ones I know about now that were authorized or unauthorized, and I do what we call AI security posture management. And in posture management, what we're looking for is to make sure that this AI is locked down and following the security policies that we have for the organization. So for instance, if it's containing sensitive information, maybe we don't want it to be public facing. If it is public facing, maybe we're going to require multi-factor authentication. We want the data to be encrypted. These kinds of things that are on the checklist, we want to make sure that this cloud instance that's running this AI is in fact following all of those kinds of rules. Then I'm going to take the model and test the heck out of it. Penetration testing. In penetration testing, I stand a model up and then I send a bunch of commands into it. For instance, like prompt injections. I'm going to send all of those into that model and see how it responds. And if it responds in a way that rejects the prompt that's being injected, then I know I'm okay. If not, well, then I'm going to realize I need to add some other things to it to put in some particular protections. Another thing I can do is for runtime, that's something we're doing before you go into production, but when you're in production, you want to put a layer of protection between you, your user, and the ultimate.
It's like a firewall.
Yeah, exactly. A firewall. We've been doing that in the networking space for ages, and now we can put an AI-specific firewall. An AI-specific firewall might go like this. We have a user here, we have an AI here, and I put the firewall in between, and now every command that comes in, every prompt that comes into it, and it gets the chance to look at it and decide, am I going to allow this or not? Are you asking me to do something that's improper? Okay, if that's the case, I'm going to reject it. If not, I'm going to let it go through. And when the response comes back, I can examine the response as well and see if somebody's done an extraction attack. So here was the protection for an infection. Here's the protection for an extraction. It looks at that and says, oh, why are you leaking a ton of credit card numbers? That's not something we want to be spilling out all over the internet. So that's the kind of construct you can put in place in order to protect your AI and put a layer of protection around it. So that's some things you can do on the governance side or on the security side. How about governance? What would you do to mitigate some of those risks and threats that we just talked about?
Yeah, I mean, when it comes to AI governance, and this is whether it's agentic or not, you really need to focus in on three key pillars. You have lifecycle governance, risk and regulation, and monitoring and evaluation. So let me just kind of break that down. This means that you have a system in place to make sure that your agents are approved for use by the right people from the initial inception of the idea all the way to production. And then you're assessing those to make sure that they're compliant with relevant regulations. And the last part of that is that they're being evaluated during development, testing, and while running in production, just to make sure they're doing things like making correct choices, routing correctly to the different agents, responding faithfully, and all that other good stuff. And at the end of this, and this is one again that's going to cross over between the two, you really need a dashboard that consolidates all this into one place for, easy compliance reporting.
Security and governance alone are just not enough. Governance without security is fragile. You can set rules for fairness and transparency, but if someone can hack the model or poison the data, those rules collapse instantly.
And security without governance is blind. You can lock down the system and defend it from attacks, but if the AI itself is biased, lacks oversight, or just can't be explained, you've just protected something that's already broken.
Exactly right. If you're going to have an AI agent that you can trust, you need to be able to both secure and govern them. Without this, there's no telling what autonomous agents will do.